All right, let's do an example problem from solving exponential equations using exponent properties. So let's start with this problem right here from the homework. 2 to the 4 minus 3x equals 16 to the 2/5. And oh my goodness, is this intimidating looking. But as we said, in class, our first step is going to be to turn this into an easier problem. And that's sort of general advice for any equation solving, any sort of math, is if you can turn it into a problem that you can work with, that's really your best hope. So let's flip over to what we took as notes for our strategies for solving this problem. All right, so our first step is to see if we can get both sides of the equation to have the same base, to be this form right here. So as a simple example, if we had 2 to the x equals 8 squared, we could turn 8 into a base of 2 because it's 2 cubed and work from there. These problems are all, I have to tell you, all possible to solve by changing the base. That's really the whole point, is that you can write these with the same base. If you couldn't, we couldn't use this strategy. We'd have to introduce something else called logarithms, and we're going to do that eventually. But for now, the problems you see can be solved this way. All right, so that in mind, our first step must be to take 16 and to rewrite it as 2 to the something. Right. 2 to the, we don't know what yet. So we'll go ahead and sort of just flip through and say, all right, well, 2 to the first, that's 2. 2 to the second, that's 4. 2 to the third, that's 8. 2 to the fourth, though, 2 to the fourth is 16. So 2 to the fourth and 16 are the same thing. So in place of 16, we can sub in 2 to the fourth. And this helps us because we have a base 2 over here. And so if we have a base 2 on both sides, we have an equation that we can work with. So we're going to substitute that in, as I said, and rewrite the equation. So on the left-hand side, we still have 2 to the 4 minus 3x. But now on the right, instead of 16 to the 2/5, we have 2 to the fourth subbed in to the 2/5. And I know you're just saying, Mr. Dahan, that doesn't actually help me. That's still crazy looking. Fair point. We are going to simplify it a little bit further because it's still not quite in this form we want it to be in. It's still not just 2 raised to something equals 2 raised to something. So we've got to use this exponent property, which says a to the m raised to the n equals a the m times n, in order to simplify this. So in this case, that means that 2 to the fourth raised to the 2/5 equals 2 to the 4 times 2/5, which is 2 or 4 to the 1. And again, multiplying fractions, you're multiplying straight across. That gets you 2 to the 8/5. And again, we're just going to sub that straight in there. And we can now rewrite our equation as 2 to the 4 minus 3x equals 2 to the 8/5. And now we've finally finished step 1. We have an equation where the base is the same on both sides. This is the important part. The base is the same. And if the base is the same and the two expressions entirely are the same, it's an equation, then these exponents must be the same. And so we can do step 2. We can write a new equation just from the exponents. So we're just going to take this and rewrite it as 4 minus 3x equals 8/5. And this is just your average everyday linear equation. Yes, it has a fraction in it. Deal. And we're going to solve. So solving, getting x by itself, means first we're going to subtract 4 from both sides. On the left-hand side, that cancels out, and you get negative 3x. And on the right-hand side, 8/5 minus 4. Not going to spend a bunch of time reviewing how to subtract fractions, but I don't mind if you use a calculator for this. That's okay. Though if, for example, you need to take the AccuPlacer, you really need to review subtracting fractions in order to get through that. So 8/5 minus 4 over 1. This is where we need to make like bases. So we're going to get a common denominator, rather. Common denominator would be 5. So we're multiplying the numerator and the denominator by 5 to get 20. And then 8 take away 20 is negative 12. So we have negative 12/5. And I prefer to keep it as a fraction. You could treat it as a decimal, but that can get ugly if you're working with thirds or sevenths. So negative 12/5. And finishing up solving this equation, which was step 3. Divide both sides by negative 3. Divide by negative 3. Again, this is dividing, including fractions. So that leaves us, I'm sorry, this was negative 3. That leaves us x equals negative 12/5 divided by negative 3. Well, a negative divided by a negative is positive. 12 divided by 3 is 4/5. And that's your answer. All right, so the difficult step, hopefully the challenging step, the new step, is this conversion of numbers to common bases. Solving equations is something you've done for years. Yes, you might run into some fractions here. I don't use a calculator as much as you need to, but be aware that often they're going to reduce to fractions. I'm not going to accept rounded decimals, so you'll be better off if you can leave it as a fraction, however you do that. And again, you know that you might have to work with negative exponent rules, so be aware if you run into fractions, that's how you'll have to deal with those. All right, good luck.